So NeuroTas life-changing ingredients. What we are is an active ingredient company. What we do is we have a groundbreaking technology that can data mine food and discover new molecules in a very fast and efficient way. These molecules can, for example, lower cholesterol, lower blood pressure, or lower inflammation. These are some examples. And how it worked is that I got some help from Nova UCD, and the thing that really helped me the most is the NDRC, and they're present here. The NDRC was really great support. I had a lot of interactions with them initially before I started working with them. They have great workshops. I learned a lot. And I made a few friends on the journey as well, one of which is John Gagan. Thanks very much for your help, John. I'd really like to thank the NDRC. They were great. They supported NeurotTas with funding, but also with a lot of workshops, etc. So basically, what's the problem that NeurotTas is trying to solve? There are 2 billion of people currently in the world that suffer from metabolic health disorders, and that includes, for example, chronic inflammation, which is at the base of everything. And if you look around, there are very, very few or no food products that address this need. And this is because food ingredients that are active, that do this, take years and millions to develop, and food companies don't have the scientific know-how to do so. So basically, what this means is that food companies cannot access this lucrative market of 60 billion only for the anti-inflammation. And then you add on all the other markets, diabetes, cholesterol, etc. So food companies cannot access this. And what's the opportunity? The opportunity is that we have hundreds and hundreds of new novel ingredients coming out every day. These are byproducts and wastes that are rich in protein. That means that they contain between 30 to 50 or more % protein. And these are ideal candidates for the discovery of natural bioactive peptides. These are molecules that reduce these disorders I was telling you about. And on top of that, they can be patented as well, which is great. So my journey was actually in the whey area, and I was telling you this earlier. I worked in milk. And whey, a few years ago, was market value 0. It was a waste. Now, the market value of the whey protein alone is 6.4 billion. And that because what they did simply was change that waste into something nutritional with a nutritional benefit. And this is what NeurotTas is seeking. We're going to find the next big way in all those ingredients. And how we work is that we use data analytics. We use multiple algorithms, machine learning, etc., to go through the billions of molecules in food and to narrow down to a select few that we go testing in the lab. Here, for example, if we start with the source material, we will analyze over 30 billion molecules. Each of those will be analyzed, and then we draw it down to a select few, maybe 100 that are tested. 6 of those will be sold in cosmetics, 5 in supplements, and 3 of those in food. And what's good about our cycle is that we do this in 6 months, as opposed to the 10-year cycle in food, or in pharma even more. So this is just a video of what is happening currently in the lab, what we do every single day in the lab. We basically write code, we code a lot, and we data mine, and we look at different proteins, and we look at different peptides, and we try and find ones that confer a therapeutic quality. So this is just a video here, and this is what we do every single day. Now, I didn't get to code for the past 4 months, but we have coders in the lab, and this is just an example of that. This is our first result, actually. The first result we got is a peptide that kills MRSA. Now, this wasn't random. We didn't find this peptide randomly. We actually analyzed billions of molecules, narrowed it down to a select few, and tested those. And what's interesting is that currently what's used is an antibiotic, but that antibiotic in the middle is much better than ours, well, slightly better than ours. But the problem with that antibiotic is that it causes a lot of hassle. They only give it when you're really dying because it can kill you as well. And it has long-lasting side effects. You can lose your legs, for example, etc. Ours is a food grade. It comes from food. Our bodies have evolved to recognize it, and it's safe. and it kills MRSA. And it comes from a byproduct, a waste, so it's very cheap to make at the origin. We have found many other molecules in the past 6 months. We have found ones that lower inflammation and are very good. Some of them are much better than what's on the market. We have found ones that increase your elasticity, so anti-aging peptides, again from food, and this again using our technology. And basically what we have achieved so far, again, creating a team. So we have a world-class advisory board, which I'm not talking about here, but gathering a team of excellent, hard-working, very good people, one of which is Cyril Lopez here. The video was his, actually. And the second thing was we're working with global food companies around the world, analyzing their own ingredients and seeing if there's anything there worthwhile for them to take further into a health benefit, a human health benefit. And working with billions of molecules. We work with billions and billions of molecules every day. Our database is constantly growing, and we're learning more and more about food. So we're basically creating the future of food. That's what we're doing every single day, and it's very, very exciting. We're based in the NDRC. And then just to finish off, I just want to see the key elements in my own background were basically multidisciplinarity. Like, it's very hard to go from one field to the other. There's a lot of challenges, but actually we do get to see another field in a very different way to the people that work in it already. So I came from a very different field, and I was solving the problems in a very different way. I think breaking into new fields is very good. To be honest with you, I didn't mention this, but when I broke into the food area, I was rejected and rejected and rejected. I kept sending papers that were pure bioinformatics to journals, to food journals, and they kept rejecting me, not based on the science was very, very good. They were rejecting me because they were saying, we do not accept bioinformatics, you need experimental work. And it took a long time to convince them that this was real. The results were real. There was no experimental work, but it's still what we were analyzing was based on data. It's based on looking at genomes, et cetera, that it was real and worthwhile publishing. So I had to do, during that period, because I'm a scientist, you need to publish. So I had to do other things on the side to keep my record, my publication record going, while trying to break into this field and convince people that it was worthwhile. And it's going very well now. It's, a lot of people have been convinced, but it took a few years. And then I think one of the main things that I learned from my PhD, being a PhD student, and simply because I chose a project where I couldn't be chaperoned, was actually going out there and getting teams together and learning from them and getting the right teams. Most of the teams I gathered and worked very well, about 90%. 10% didn't work, but that happens. So that was great. And then thinking outside the box, I think, is very, very good. It connects very well to breaking into new fields. Thank you very much, and thanks for inviting me.